Ignite is an ongoing series of speedy presentations. They've ranged from building multi-person pogo sticks to hacking chocolate. Any topic that geeks hold dear. Each speaker gets only 5 minutes and 20 slides that auto-advance every 15 seconds. The talk you're about to hear was recorded live at one of the featured Ignite events around the world.
And so we're going to kind of see the math behind randomness. Sean is a web developer and math guy here in Reno. So without further ado, Sean.
I'm going to mess this up. Fair warning. All right. So my name's Sean Williamson. I'm a web developer in Reno. I studied mathematics in college, and so I really like it.
Silver mic.
Silver mic. I'm in the silver mic. Okay. So what is randomness? That's going to be the topic here. And I originally thought that maybe I would do like a mathematical definition of randomness, but I ended up thinking that I should talk more about mathematics and perception, randomness. So anyway, this is the standard definition of randomness. There's two primary definitions. One is the scientific definition, which is incredibly rigorous, and the other is the slang definition, which we abuse every single day. So if something's truly random, you cannot predict it. That's essentially what it comes down to on the science side. You don't really know. Like, you can't tell if it is. You just know that it likely is. So, also, and then we have the slang version, which is, Becky's really random. But is that really true? I mean, is she? From her point of view, she's absolutely not because she thinks about it. But from my perspective, she might be because I have no idea what she's thinking. So it's kind of a problem, right? And, you use this to great comedic effect. And you wind up with things like Robin Williams doing a bunch of cocaine and getting up in front of a microphone and just talking for like 20 minutes about nothing. It ends up being hilarious because you have no idea what his thought process is. Hence the potato. If I just had to point that out. So Becky really isn't random. She's an individual, she thinks, she moves, she does everything in the way that she thinks that she should do it. But to an independent person, probably a little bit weird. But if you actually met somebody who's truly, truly random, I would be terrified. Personally. I have no idea what they're going to do. Any given moment, they might sublime into gas. Freaky. So you can't really tell if something's random. You can only say it's probably random, which is a very strange concept from a science perspective, right? So randomness originally was studied in all of the ancient cultures basically with dice. And it started out being a study of games of chance. And so what this means is it wasn't formalized for a very long time. It started out being studied in ancient China and Greece, 3000 BC, and it was formalized in the 16th century in Italy and during the Renaissance period. In day-to-day life, it's incredibly important, specifically in my field, and I know anybody here who works with electronics or security or email, use email. Randomness is great for email. So, I don't remember what the next slide is. Why do we study it? We study it precisely because it is important for things like that. So anytime that you want a computer to communicate to another computer securely, it's based on randomness. You have to have randomness or a random seed in order to have a secure connection in between 2 points. So crazy people study it, and mathematicians, they're not quite the same thing. They're similar, but not the same. Although some people might argue the other way around.
Come on, say something!
Something. All right, so these are a couple things that are not totally random, but I actually think that they're very interesting, specifically from talking about perception of randomness versus actually being random. We're going to start off talking about Conway's Game of Life, which many of you know is not random, but it can be started from a random state and you achieve stability through it. So Conway's Game of Life is an extremely simple program, mathematical program, that runs with 4 basic rules. And from those 4 rules, in any initial state of the system, you wind up with these really crazy looking patterns. To somebody who doesn't necessarily know what it is, it looks completely random, right? But it winds up that you get this beautiful symmetry and systems that are self-evolving, and you wind up with stability from randomness. And I find that to be an incredibly fascinating concept. If you're bored, it's almost over. So random walks are another principle that's incredibly important in all studies of sciences. Random walk means that if you have a person, they can go left, right, up, down, with random probability at any given time. Now, it turns out this is incredibly important for neuroscience, for studying Brownian motion, for a lot of standard distributions and statistical methods. It's very important. But, this could be a grid of a city. It could be a bus map of Chicago. I don't know. I've never ridden the bus all the way around in Chicago. It's a little complicated. But I find it to be pretty. Pi Pi's awesome. I've never met somebody who liked mathematics who didn't like pi. I hope all of you like pi. Pi is delicious, right? Pi is delicious. All right. So part of the reason I'm bringing up pi is because I recently learned this. I didn't know, but it turns out that pi, after its first decimal, is effectively random. There's 6 billion digits that are non-repeating that follow a standard normal distribution that have been proven to be probably random. So we're going to talk a little bit about a really crazy experiment called Buffon's needle, which effectively means I take a bunch of toothpicks, I throw them at a bunch of lines that I drew on the ground, and by studying the number of toothpicks that cross the lines, I can wind up at an approximation for pi. And it turns out that if you do this with the right length of toothpick and the right length of grid, you wind up with an approximation of pi that is up to 10 to the negative 7th accuracy. So you go from something that looks random, you throw it at the ground, and you actually get a random number out of it. And it's nuts. Anyway, that's my presentation. Thanks very much. Math is awesome.
Thank you, Sean. So how many people were expecting a math lesson when they came out to drink tonight? How many people in the way back were expecting this to happen tonight? Okay, a couple people. So thank you, Sean. That was great.